Last video, we learned while loops and for loops from scratch. And at the end, I gave you a challenge, a number guessing game. I told you to build it yourself before watching this video. If you did, good. You are about to see exactly where things can go wrong and why. If you did not, that is fine too. But I want you to actually open your editor right now and follow along as we build it together. Because today is not just about reading mistakes on a slide. We are going to write broken code on purpose, watch it fail, understand why, and then fix it live. That is how this actually sticks. And yes, we are also revealing the full solution to the challenge at the end. Let us get into it. Okay, mistake number 1. And this is the one that every single beginner hits at least once. The infinite loop. Let me write a simple counter. I am creating a variable called count and setting it to 1. Now I am writing the while condition, while count is less than or equal to 5. And inside, I want to do something each time the loop runs. Type count equals 1. Now watch what happens when I forget one thing. I'm going to run this. Type the while loop without the update line and run it. Your fan just turned on, right? The program is frozen. Nothing is happening. Or worse, it is printing the same thing forever and you cannot stop it. This is an infinite loop. Press Ctrl+C to kill it. The reason is simple. Count starts at 1. The condition says while count is less than or equal to 5. Is 1 less than or equal to 5? Yes. So the loop runs. Is 1 still less than or equal to 5? Yes. Count never changed. It is always 1. The condition is always true. The loop never ends. The fix is one line. I add 1 to count each time. Type count plus equals 1. Run it again. Now count goes 1, 2, 3, 4, 5. When it hits 6, the condition is false. Loop stops. Clean. Rule to remember forever. Every while loop you write, before you run it, ask yourself one question. How does this loop end? If you cannot answer that clearly, you have probably written an infinite loop. Mistake 2. This one is sneaky because your program does not crash. It just gives you the wrong result. Quietly. No error message. Just wrong. I want to count from 1 to 5. Let me write the condition. While count is less than 5. Looks right, right? Let me run it. It printed 1, 2, 3, 4. 5 is missing. The loop stopped one step too early. Here is what happened. When count reached 5, Python checked the condition. Is 5 less than 5? No. So it stopped. It never processed 5. The fix is one character, less than or equal to. Run it. Now we get 1 through 5. Perfect. The same thing happens with for loops and range. If I write range 5, I get 0 through 4. 5 items, but they start at 0. If I wanted 1 through 5 specifically, I use range with 2 arguments. Start at 1, end at 6. Because range always stops 1 before the number you give it. Whenever you are not sure about your loop boundaries, slow down and walk through the first run and the last run in your head before you run the code. What is the value on the very first loop? What is the value on the very last loop? Does that match what you actually want? Mistake 3, and this one is pure Python. Indentation. In Python, indentation is not just style, it is structure. It tells Python what is inside the loop and what is outside. If it is wrong, your logic is wrong, even if everything else looks perfect. Here is a common version of this mistake. I have a loop that counts up, and I want to update the counter at the end of each run. But watch what happens when I put the update line in the wrong place. Type the loop with count plus equals 1 accidentally outside, not indented. Run it. Frozen again. But this time, the code looks almost right. The update line is there. It is just in the wrong place. Because it is not indented, Python thinks it is outside the loop. So the loop runs, count never changes inside, and it runs forever. Fix. Indent the update line so it is inside the loop body. Fix the indentation and run again. Works perfectly now. The opposite mistake also happens. You put something inside the loop that should only run once at the end, like a final message. Because it is indented, it prints on every single run instead of just once. Rule: if it should happen every repetition, it goes inside, indented. If it should happen once after the loop is done, it goes outside, not indented. Mistake 4 is less of a crash and more of a habit. Using a while loop when a for loop would be cleaner. I see beginners do this because they learn while loops first and then just use them for everything. It works, but it is harder to read and easier to get wrong. Simple rule: if you know exactly how many times something should repeat, use a for loop with range. Cleaner, safer, less to manage. If you are waiting for something unpredictable to happen, user input, a condition that depends on outside data, something you cannot count in advance, that is a while loop situation. The guessing game we are about to build is a perfect example of when a while loop is exactly the right tool, because you have no idea if the user will guess right on the first try or the 20th. Okay, the challenge from last video, the number guessing game. Let me first show you a broken version, the kind of code that looks right but has problems hiding inside it. I'm setting the secret number and a guess variable. Then the while loop condition. Keep going as long as the guess is not equal to the secret. Inside, I'm asking the user for input and storing it directly. Then a simple if-else to tell them if they are close. It crashes. Or it behaves completely wrong. Can you see why? The input function always gives you back a string. Always. So we are comparing a string to a number, and Python has no idea what to do with that. No error about the loop, no error about the condition. Just broken behavior because of one missing step. Run it again. Type a wrong number. Okay, it runs now. But something is still missing. There is no feedback about how many attempts the user has made. No counter anywhere. This is exactly how real debugging works. You fix one thing, run it, find the next problem, fix that. Step by step, never all at once. Now let me build the clean version from scratch so you can see what the complete solution looks like. First line, the secret number. I'm just setting it as a variable. Then two more variables before the loop even starts. One to track how many attempts the user has made, starting at 0. One for the guess itself, also starting at 0. That last one is important. The while condition needs guess to exist before the loop begins, otherwise Python will complain. The condition is simple. Keep looping as long as the guess does not match the secret. Inside the loop, first thing we do is ask for the guess and convert it to a number in the same line. Then immediately add 1 to attempts. Every single run of the loop, the counter goes up. Then the if and elif. Too low? Tell them. Too high? Tell them. If neither of those is true, the loop condition handles it. The guess match the secret, while becomes false, and we exit. And the final message goes here, outside the loop, not indented, because this should appear exactly once, when the game is over. We can show them how many attempts it took right in this line. Run it, play through it, it works. Every single mistake we covered today, the infinite loop, the off by 1, the indentation error, the missing type conversion, they all have a home somewhere in this project. That is why I gave it to you as the challenge. If you tried to build it yourself, you probably hit at least one of them. So to wrap up, loops are not hard, but they fail in very specific ways. Infinite loops when you forget to update. Off by 1 when your condition boundary is slightly wrong. Indentation errors when code ends up in the wrong place. And type errors when you forget that input always gives you a string. Now you have seen all of them break live, and you have seen the fixes. Next video, we are adding 3 new tools to your loops: break, continue, and pass. Each one gives you more control over what your loop does and when it stops. And right after that, we are getting into lists, one of the most important things in all of Python. Creating them, accessing items, slicing them. It is going to open up a lot of doors. If you made it this far, subscribe, because those two topics together are where Python starts feeling really powerful. See you there.